Algebra 2, Chapter 5.3, Solving Linear Systems in 3 Variables. In the previous video, we showed how to solve using substitution. In this video lesson, we're going to stick to elimination. And what we're looking at graphically is something like this, where you have 3 planes that intersect at one point, and that one point will be the coordinate triple that will be the solution. Okay, so I'm going to go here. Let's see, that's these numbers 2 and 3 we solved in the last video. Here we have explain 2, solving a system of 3 linear equations using elimination. So you start with the 3 equations and you reduce these 3 equations to 2, and those 2 to 1. You solve and go backwards. And so here is the first example that I'm going to do, and I'm going to explain what happens here. To me, this is more systematic than solving by substitution, in that the first thing we're going to do is take these 3 equations and we're going to reduce those 3 equations to 2, and then after we do that, we're going to come over here and take these 2 equations, the 2 resulting equations, and reduce those to 1, and then we're going to solve for our first unknown. And then after we solve for our first unknown, we're going to work backwards and find the remaining 2 unknowns. So what you're going to look for in the first is you try to look for making things as simple as possible, where you might have, like you have 1z and negative 1z, you have 2y, y, and y. I'm going to try to eliminate z first. What I'm going to do is take these first 2 equations and add them to each other. So we have x plus 2y plus z is equal to 8. And so that's this equation right here. And next we're going to take the equation immediately underneath, this one right here, and put it right underneath this other one. And to do that, we put 2x plus y minus z is equal to 4. Now, if we take the second equation and we add it to the first, I'll put a plus sign out here, we're going to have x plus 2x equals 3x. We're going to have 2y plus y equals 3y. We're going to have z minus z equals 0. And finally, to the right, we have 8 plus 4 equals 12. So now we've gone to 2 equations. And in the spirit of continuing to solve to eliminate z, we're going to take this third equation, which is x plus y plus 3z is equal to 7. And then we're going to bring back this second equation. So I'm going to go arrow down here. We're going to take this second equation and put it underneath the other one. Now, what we have in our second equation is we have minus z, so we're going to multiply that second equation by 3. So 3 times, let me make another little more room here. So 3 times 2x plus y minus z equals 4. And we're going to subtract. Now you can do these all in your head like this, like we have. What we have is x minus, actually we're going to add these together. Oops. Add 3. Okay, let's see why, because we're going to eliminate this z. So we have x plus 3 times 2x is going to be 7x. And then next we have y plus 3y is going to be 4y. And then the last one we have 3z plus negative 3z is going to equal 0. And then the last one we have is 7 plus 3 times 4. Well, 3 times 4 is 12. So 7 plus 12 is 19. So now we have 2 equations. Now I'm going to bring these 2 equations to the right. We have 3x plus 3y equals 12. And we have 7x plus 4y equals 19. Okay, I get this plus 4y. We can't add or subtract these quite easily to eliminate variables, but what we're going to do is we look for, what we're going to do is take, we have this 3y and this 4y. If we multiply this top equation by 4, and we multiply this bottom equation by -3, we are going to have, we're going to be able to cancel the y's. Okay, let's look at this. 4 times 3x is 12x, and 4 times 3y is 12y, and 4 times 12 is 48. And then for this bottom equation, -3 times 7x is -21x. And then -3 times 4y is -12y. And then finally, -3 times 19 is going to be -57. And now we can add these 2 equations to get one. So 12x plus -21x, that's going to be -9x. And then 12y minus 12y simplifies to 0. And on the right side, we have 48 minus 57. That's going to be -9. And so now we solve for unknown. I bring this -9, x minus 9 equals -9. We divide by -9. We have x is equal to 1. And now we can go back to one of our equations earlier. So I'm going to take this first one. We take 3x plus 3y equals 12. We're going to substitute in 1 for x. So we're going to get 3 times 1 plus 3x, or plus 3y, is equal to 12. And so if we subtract 3, we get 3y is equal to 9, and therefore y is equal to 3. Okay, so there's y. And now we can bring along the x equals 1 and y equals 3, and we can substitute them into one of these other equations. So I'm going to take the second equation. We have 2x plus y minus z equals 4. So we're going to take these two unknowns we've solved for and substitute them into this equation. When we do that, we're going to have 2 times 1 plus y, which is 3, minus z is equal to 4. On the left side, we have 5 minus z equals 4. We subtract 4 from both sides. We have 1 minus z equals 0. And so we have, adding z to both sides, z is equal to 1. So now we have x, y, and z. So our ordered triple as opposed to an ordered pair is going to be the coordinate triple 1, 1 comma 3 comma 1. Okay, let's go ahead and try this out. If we have x equals 1 plus 2 times 3, that's going to be 6, plus 1, that's going to be equal to 8. Check. If we have 2 times 1, that's going to be 2, plus 6, that's going to be 8. 2 plus 3, 2 plus 3 minus 1, that's going to be equal to 4. Check. And then we have 1 plus 6, and we're going to have actually 1 plus 3, not keep them straight, plus 3 is equal to 7. Check. So these all check. We know we have a good ordered triple right here. And that's it. Next problem, I invite the viewer to work out this system here. And I'll pause the video, see if you can work it out, and then play ahead to see if you got it right. Okay, playing ahead, I worked all this out and went from 3 to 2, and I showed the arrows of the equations being worked out. The first thing was done here was eliminating the y with these two remaining equations. We eliminated the z, and then finally you had an equation for x, 3x equals 6. You're going to solve for x, and then work backwards to find what z was, and then finally what y is. And then we're left with our ordered triple, which I did test up here. I mean, I like this a little better overall than substitution, because it just seems like there's more of a logical, replicable way of doing this. I hope this has been helpful to you. Good luck, and thanks for viewing.